This is the demo video for the recommendation system on the Yelp dataset. We use PySpark here in this Google Colab notebook to statistically subsample the Yelp dataset so that we can target an average person and an average business and create a recommender system for these businesses and users. Here we start by installing PySpark and HandySpark, which we use for extra things that PySpark doesn't provide, and also PySpark Dist Explorer. These are libraries to help us explore the data and create visualizations. And then we import all the libraries that we need. We mount our Google Drive, set up our directories, and then we unzip the Yelp dataset, which is located on our Google Drive. And then we set up the directory for the unzipped Yelp file. We initialize our Spark session. What we learned is that we want to set the local to star, so we use all of the cores on our CPU on this Google Colab notebook. We set the port, which we later use to tunnel through to get to. And then we have our, we set how many Spark executors we want. We set how much memory we want an executor to have and a driver to have. This is very important to improve our performance so that we can run this. And then we set a checkpoint directory so that as we run, we can keep clearing the RAM and have it saved in case anything crashes. And then we create this Spark session. As you can see here, it creates a UI. This would be a link for localhost, but since this is a virtual machine, we need to set up ngrok tunneling, which is installs an agent on the drive, and this should not be visible, and sets up a tunnel so that localhost tunnels out through here. And so here's our Spark session. And it's exposed out to the internet using ngrok. For our exploring the data, we read in our JSON data set from the Yelp data set, and then we look at our schema. We see that some things need changing. We look at the first couple of rows of the data, and here we see that we don't have any nulls, and we change our date variable to a timestamp so that we can look at time series stuff. And then we also look at how many reviews each user leaves. So the top reviewers leave around 3,000 and the thousands of reviews, but the average reviewer leaves between 3 to 4 reviews. So we can see this very wide range in our histogram for how many reviews each reviewer leaves. And so by this data, we decide to split. We need reviews from reviewers who leave at least 50 reviews and at most 100 reviews. And when we look at the histogram here, we get a good chunk of people, and we reduce our data set quite significantly from 2 million users to around 8,000 users. This is mostly because we removed the first reviewers who leave less than 50 reviews, which is not enough reviews left by those reviewers to make a good recommender system. We later do the same thing now with businesses. So we look at the top businesses get 8,000 reviews to 3,000 reviews, but the average business gets around 50 reviews. So again, we look at the histogram, we see we have this wide range. We say each business needs at least 100 reviews and at most 500 reviews to count as an average business for us. And then we see this nice histogram of a lot of more common businesses that we can make recommender system out of. And then we further filter out their reviews, looking at how each review is rated. If each review is either rated as useful, funny, or cool. Some reviews are rated as very cool, while other reviews are rated as funny or useful. So what we do here is we look at the histogram of how many reviews are rated as useful. So for example, you might get here we can see for useful a review can have 70 a rating of 70 of being useful, so it's been upvoted as useful 70 times or by 70 different people. But on average, we can see that review gets marked as useful only like 2 times, and funny maybe 1 time, and cool maybe 1 time. While sometimes they get 71 reviews for cool or funny. So we filter out this data as well. We can see here where there's a large similarly large distribution where most reviews really don't get a lot of upvotes on these ratings. And so we don't want any reviews that are too cool or too funny or too helpful, because they're probably commercial reviews or just non-standard reviews that a lot of people get to see, but maybe are not good for seeing or making a model out of people's preferences. So this is what we do here. We say, okay, the max funny, useful, or cool upvotes that a review can have is 20, and we cut down only a very small amount of the data, but still outliers. And so now we can see a better distribution again for the useful, funny, and cool data set. And we don't really cut the data down much. And then we also look a little bit at how many reviews are left over time. We can see that we have a very sporadic data set here. We're going to do more analysis on this if we see that it's useful. But mainly it's a pretty constant amount of reviews over time. The reason it's so jumpy is because it is per second, and so you might have very little in 1 second or a lot in another second. So we need to average out this to make it look more flat, but still be a very flat line. Now for the collaborative filtering part, we use the ALS, which is alternating least square algorithm, for the singular value decomposition method for doing collaborative filtering. Basically, it just creates a matrix of businesses and users and ratings, and then figures out what other 2 matrices multiplied together make that matrix, and it figures out what those submatrices are. And it has each one of those matrices basically has a latent space that represents like user preferences or business preferences. So here we use our Spark session. We need to create an indexer on the user ID and the business ID field. What that means is we need integer values for these fields rather than these complicated strings for the algorithm. So it just indexes each of the unique IDs into an integer. And so here we can see we got our business ID and user ID, but we also have our business ID and user ID integers, which is used for the algorithm, and then we also use the stars, which is the rating for our algorithm. We do a train test split of 80-20, and then we make sure to cache our training data before we run this so that Spark doesn't crash, and then we train using our grid search. We try a rank of 5, a rank of 10, and a rank of 15. We try max iterations of 5, 10, and 15 and a regularization parameter of 0.1. Using a root mean square error, we evaluate our resulting model. We see that the best model that we get is a rank 15 with 15 max iterations and a regularization parameter of 0.1. This means that we can probably increase the rank and increase the max iterations and see if we can get a better model. But this is just increment 1 right now. And we can see that with that best model, we get a root mean square error of 1, basically, which is really good for a 200,000 data set, 200,000 size data set. We save our model so that we can load it again later, and then we run the predictions using this model to see kind of on a chunk of data what the model would predict. And we can see just like out of the small subset of the data, it's pretty good at predicting. So here it predicted that this user and business combination would be around 3 stars, and it was. Here it predicted 3.5 and it was 2, which is not too far apart, but most of these are not too bad. Some of these are pretty good, some of these can be improved, but again, being 1 rating apart or half a rating apart is not bad for just this initial iteration.